Alright, the body temperature of female mammals varies over a fixed period. For humans, the period is about 28 days. The temperature T in degrees Celsius varies with time T in days and can be represented by the cubic function T of T is equal to negative 0.0003 T cubed plus 0.012 T squared minus 0.112 T plus 36. Determine the critical numbers of the function. The female is most likely to conceive when the rate of change of temperature is a maximum. Determine the day of the cycle when this occurs. Okay, so let's find the critical numbers of the function. So to find the critical numbers, I need to find the first derivative. So I'm going to find t prime of t. So I'm going to do the derivative with respect to dt of negative 0.0003 t cubed plus 0.012 t squared minus 0.112 t plus 36. Okay, so if I do the derivative here, t prime of t here is equal to negative 0.0009 t squared plus 0.024 t plus 0.112. Okay, and then to find the critical numbers, I'm going to let t prime of t equal 0, right? So then we're going to get negative 0.0009 t squared plus 0.024 t plus 0.112 is equal to 0. Right, so you can notice that it's equal to 0. If you want to solve for t to find the critical numbers, you need to use the quadratic formula. So t is equal to negative b plus minus b squared minus 4ac over 2a. So I'm going to solve for this by plugging in the values. So t is equal to negative 0.024 plus minus b squared, which is 0.024 squared minus 4 times negative 0.0009 times 0.112. Okay, let's just say that this is all within the bracket. And then it's 2 times negative 0.0009. Okay. We need to also understand that when we do solve for this, that t has to be greater or equal to 0, right? So you can't have a negative value. So if you plug this in, I'm just going to use my calculator. Now just notice the mistake here. So this point here should be negative, because there's actually a negative value here. So I'm just going to recorrect that. So that will change our answer. So I'm just going to recalculate this. And the positive value that I calculated was 20.64 days, right? The negative value that I actually calculated here was negative 60.30. Okay, so this value won't work because time has to be greater or equal to 0, right, in days. So our value here is 20.64 days. So at 20.64 days, because our first derivative function does employ a critical number, we should have a maximum or minimum point here, right? So there's the critical number that we only have here is 20.64. I'm going to plug this into my function t of 20.64, and this is going to give me, and I plug this into my original function here, this is going to give me approximately 36.16 degrees Celsius, right? And this is really telling us that at the 20.64 mark, right, at this point, in this many days, the temperature is going to be 36.16 degrees Celsius. And we know that this point is an extrema, we just don't know if it's a minimum or maximum. Actually, we can determine this by finding our second derivative, right? So let me just do that. So here's my function, right? This is my original function. I want to find the second derivative to that function. So I'm going to, well, sorry, this is my first derivative function. If I want to find a second derivative, I'm going to find the derivative of my first derivative function, which is negative 0.0018 t plus 0.024. Okay, and we want to test to see if this critical number here, right, so this is our critical value or critical number, we want to see if this critical number is a maximum or minimum point. So what I'm going to do is I'm going to plug in t double prime of 20.64. We can understand that from our discussion of the second derivative, right, if f of f double prime of x is greater than 0, then the graph is going to be concave up, and if it's a critical number, right, if this is a critical number, then this critical number would be a minimum point. And if f double prime of x is less than 0, it's going to be concave down. And if this point here is a critical number, then this is going to be a maximum point. Okay, so if I do t of 20.64, whoops, if I do t double prime of 20.64, if I plug this in, I'm going to get negative 0.0018 times 20.64 plus 0.024, and that's going to give me approximately negative 0.013. So this tells us that the second derivative, 20.64, is less than 0, so it's concave down, and this is a critical number, so this has to be a maximum point. Okay, so this is a maximum point. So this tells us that there's going to be a maximum temperature in 20.64 days of 36.16 degrees Celsius. Now for part B, the female is most likely to conceive when the rate of change of temperature is a maximum. Now when we're looking at rate of change of temperature, right, we need to find a maximum of the rate of change. So we need to first look at our rate of change function, t prime of t, right? Determine the day of the cycle when this occurs. Now, to find a maximum of a rate of change, you actually need to find the derivative of the rate of change function. So the derivative of the rate of change function, and this is basically our rate of change function, t prime of t, the derivative of the rate of change function was indicated in the second derivative. So this is your derivative of the rate of change function. If you want to find the maximum, you find the critical value of this. So we let t double prime of t equals 0, so we get negative 0.0018t plus 0.024 is equal to 0, and then I move the 0.24 to the other side, so you get negative 0.0018t is equal to negative 0.024, then you divide by negative 0.0018 to both sides. Okay, so when I do that, this guy cancels out, negatives cancel out, and therefore t is equal to about 13.33 continuous days, right? So let's just round it to 13.33. Okay. So on the 13th and 1/3 day, you're basically going to get the maximum rate of change, right? So we want to figure out what the temperature is, determine the day of the cycle when this occurs. Well, they only just asked the day, so this is basically the 13th and 1/3 day, but if you wanted to find temperature, you can plug it into the function, right? So for therefore, our therefore statement, so therefore the maximum rate of change of temperature occurs at the occurs on the 13th and 1/3 day.